Okay, Cedar Crest Chargers, I'm going to teach you how to find the domain and range of a quadratic without graphing them. There's a couple relatively simple steps. I'd like to say that for the most part, the domain will always be all real numbers. Sometimes the domain isn't always all real numbers because of a particular situation. You know, you may be there may be a particular situation in which negative inputs make no real life sense. But if you just take a straight quadratic, the domain would be all real numbers because there's no limit to what x could be. So let's just make sure that that we understand that the domain would be all real numbers for the most part. But really, we need to look at a couple things. We need to know two things. We need to know where the vertex is, and we need to know where the y-intercept is, so that we can figure out whether our parabola is going is increasing, or if the range is decreasing from the vertex. We need to figure that out. So we've got a couple different ones here, and so we're going to just start with this one. On this particular parabola, the y-intercept is the c, which is positive 1, and on this one it's positive 5. So what I'm going to do is I'm just going to go over here, and I'm going to label where the y-intercept is here at positive 1, and we'll say this one is here at positive 5, and we'll just keep that for later. The second thing we're going to do is we're going to use this little formula to find the to help find where the vertex is. So we're going to find the x-coordinate of the vertex, and then find the y-coordinate of the vertex. So remember, this is the A, this is the B, this is the A, this is the B. And so I'm going to go ahead and plug those numbers in. The first one is h of x equals 2x squared plus 4x plus 1. So it's the opposite of b. B is 4. Okay? Divided by 2 times a, and a just happens to be 2. So on this one, it's, let's see, it's 4 over 4, so it's negative 1. Okay? That's the x-coordinate. And so then we would plug that back in to find the y-coordinate. So we're going to do that. 2 times negative 1 to the second plus 4 times negative 1 plus 1. And when you do the mathematics there, you get the number 2 here, you get the number negative 4 here, and you get the number positive 1 here. And that all makes negative 1. So on h of x, we get a vertex of negative 1, negative 1, negative 1, negative 1, which means the vertex is here. So if the vertex is there and the y-intercept is here, that means that that parabola is going like so. Okay? So when we want to talk about the range, we can clearly see that our y's, or our outputs, are getting bigger than negative 1. Okay, so we would say range is bigger than or equal to negative 1. So when you talk about domain and range, that would be the range for h of x. Now we'll do the same thing here for this other one. Not to confuse you, I think I'll just do it in blue, if that's okay. So it's the opposite of b. B happens to be negative 6, doesn't it? See that? Negative 6. Okay? So it's the opposite of negative 6 over 2 times a, and a happens to be 3. So 2 times 3 is 6. So what we have here is that becomes positive 6, that becomes positive 6, and that means that our axis of symmetry is at positive 1, and we need to find the y, or the output. Okay? So all we have to do is go over here and put positive 1 where we see x, so that's 3 times 1 to the second, minus 6 times 1, plus 5, and it looks like that is 3. This is negative 6, and this is positive 5. So if I add all those together, I get 8 and negative 6, so that's a positive 2. So on this one, the vertex is at 1, 2. So it's over 1, it's up 2. Let's say that's where 2 was, and that's where 1 was. That is the vertex, okay? Okay, so that's our mark there. So we would say our range on this one is larger than or equal to, and how high is it? Well, it's at positive 2. So that's the range. So that's how you find the domain and range of a quadratic without actually graphing it. We kind of graphed it, but we need to know the y-intercept, and we need to know whether that is taller, is it higher, or is it bigger than the y-coordinate, right? Is the y-intercept bigger than the y-coordinate? That would help us figure out the range. Bye now.